Hi, for this video I wanted to show you how you solve an exponential equation that has the same base that ends up resulting in a quadratic equation. So with this, what we want to do is we want to rewrite both sides to have the same base. So in this case, the base that I want to have is base 3. So the left-hand side already has 3x squared minus 7, so it already has base 3. I want to rewrite 9 as base 3, and so 9 as base 3 is really 3 squared. So I really have 3 squared to the 3x power, and remember that when you have a power to a power, you multiply exponents. So I have 3x squared minus 7 equals 3 to the 6x power. Okay, so now once you have both of them to have the same base, once this number is the same, in order for these two expressions to be equal, the exponents must be equal to each other. So x squared minus 7 equals 6x. And this method will not always work because there are times that you need logarithms because there's no way to get these to be the same base. Okay, but if you can get them to be the same base, it's the easiest to solve. So what we want to do now to solve this equation is we want to find, or the first thing that we need to do is get this in standard form where it equals 0. So let's do that before I try to find the numbers that multiply together. So standard form, remember, is x squared and then my x term. So when the 6x moves to the other side, it becomes negative 6x. Minus 7 equals 0. And so we want to figure out what two numbers multiply together to give me negative 7 that add up to be negative 6. So with this, the only two that multiply together to give me negative 7 are negative 7 and 1. And as far as which one has to be negative, you want to make sure that the larger number is negative since the middle term is negative. So I would do a negative 7 and a positive 1. Okay, so if I solve both of these, x is either 7 or x is negative 1. So what we're going to do is we're going to plug both 7 and 1 into this expression right here to make sure that it does work. You can plug it back into the original one and just plug it into your calculator. But since I've already simplified both of these to be the same base, it's the easiest way to check by hand. So I would have 3 to the 7 squared minus 7, and we're going to ask, does that equal 3 to the 6 times 7? So if we simplify this side, 49 minus 7 gives me 42. And this side also gives me 42. So this is really 3 to the 42nd power, which is a very large number. So it's possible you could get an overflow error on your calculator with that one. Okay, for the next one, if we check the negative 1, we would have 3 to the negative 1 squared minus 7. And we're going to see, does that equal 3 to the 6 times negative 1? So if we simplify this, this becomes positive 1 minus 7, which gives me negative 6. And 6 times negative 1 also gives me negative 6, so we can see that both of our answers make sense in our original problem. As always, thanks for watching. If you have any questions, please let me know. Make sure to check out all of my other video content, and if there is something missing that you need help with, please let me know.